So we've looked at the theory behind geometric sequences and series, how to calculate various terms of it, and several properties and skills that we have to be able to do. What I want you to do is, in this video, there's a couple of questions for you to have a crack at. So I want you to pause the video, have a go at the questions, then come back and check your answers here. So, here you go. First one is I want you to find the 12th term of that geometric sequence given there. Second one, I'm giving you two terms in the sequence. I want you to define the sequence, i.e. what is un, the nth term. And then the third one is an application of it. So looking at interest rates within a bank, how can we work a geometric sequence into that? So pause the video and have a crack at these questions. So the first question, find the 12th term of the geometric sequence given by this. So 4, 1.2, 0.36, 0.108, and so on. Remember, for a geometric sequence, un equals a r to the n minus 1. So we want that for when n is equal to 12. But for this, we need to know what a is and we need to know what r is. But remember, we can just straight away say what a is because it's the very first term, what we start with, and in this case it was 4. R, remember, is our common ratio, so to do that, we look at the ratio of two consecutive terms and what causes their increase. So in this case, I'm just going to look at the first two terms. So to get my common ratio, I do 1.2 divided by 4. Remember, it's un plus 1 divided by un, not the other way around, just because it's a bigger number. So if I do 1.2, divide that by 4, I get a common ratio of 0.3. So from that, I can write that this sequence is given by un equals 4 times 0.3 to the power of n minus 1. Great, I've got my format for it, now I just have to calculate the term. So in this case, I want u12. Well, to calculate u12, all I simply have to do is do 4 times 0.3 to the n minus 1, so to 12 minus 1, so to the power of 11. Then we just fire in a calculator and we see what we get. When you do that, for this one, you get 0.0000708,588. Some calculators will come up with 7.08588 times 10 to the negative 6. Some calculators may represent it in that format using scientific notation. Either version will be fine unless a question asks you for a specific format. Job done. So there you go, there's the 12th term of that sequence. Second question was if I give you the 6th term of this geometric sequence, along with the 3rd term, I want to define the sequence. So in this case, what I want to know is, what format does un equals ar to the n minus 1 take for a and r being known? So remember, in order to get this, the first thing we have to do is figure out r. Well, if I've got the 6th term of the geometric sequence, so u6, what that means is I've got a r to the power of 5, and I know it's equal to negative 486. My 3rd term, u3, that's given by a r squared, and we know that that is equal to 18. If I take the ratio of these two terms, so I do ar to the 5 over ar squared, I know that that's going to equal r cubed, and to get the r cubed, again, I just take the ratio of negative 486 and 18. So if I do negative 406 divided by 18, what I end up getting is negative 27. So all I do then, if I know that that's what r cubed is, I simply take the cube root of negative 27. Cube root of negative 27 from r is given by negative 3. So we know the common ratio. What we do is we plug it back into one of these two, we can find our a and then represent the geometric sequence from that. Keep it as simple as you can, so I'm going to go for this one here, the ar squared. What I know then is that a times r squared, so times negative 3 squared, equals 18. Negative 3 squared, what that means is I've got 9a is equal to 18, 9a is 18, a is quite simply 2. Now this is the key stage at this point. Great, we've found a and we've found r, but we have to make sure we now represent the geometric sequence by substituting these in. It's not enough to just calculate A and R. We have to tell them what is the geometric sequence. So at this point, I then have to say, therefore, I know that un is equal to 2 times my r, which is negative 3 to the power of n minus 1. So now we're done because we've said what the geometric sequence is. We've defined the geometric sequence in terms of the a and the r being numerical values. The last question was a bit more of an application question. So a deposit of £500 earns interest at a rate of 5.5% per annum. Calculate what the balance will be at the end of the 6th year. So again, this takes the form of a geometric sequence. un equals ar to the n minus 1. The reason we know this is that it's going up by a set interest rate every year, which is a multiple of the previous amount. So in terms of that, we can tell that it's going to go up by some sort of a common ratio every single year. Think back though to when we did this previously, because this has the same format as a compound interest question. So for a compound interest question, which we did way back at National 5, we had a times 1 plus or minus our interest rate, which we'll call I, to a set power. This is a similar format. Now for this, we know that the A is the initial amount, which in this case is 500. That's the exact same as we had before. A was whatever you deposited or whatever you started with. We then had our interest rate, which was this part here. Now this is the equivalent of our common ratio. So for our common ratio, what we have to do is figure out what is going up by every year and represent it as a decimal. Well, for the common ratio, we know it's going to be the 100%, so the original, so 1, plus this percentage every year, so plus 0.055. So I know that my common ratio is going to be 1.055. So I can represent this as un equals a, 500, times the 1.055 to the n minus 1. Great. Now we just have to figure out what the balance will be at the end of the 6th year. But here is the interesting part. We have to think logically about this. U1 is the start amount. U2 is the amount at the end of the first year. So the second term is at the end of the first year. U3 is at the end of the second year. So it's the amount going into my third year, which I start with. U4 is the amount at the end of the third year, which I take into the fourth one. So for the amount at the end of the 6th year, that's the equivalent of the amount I'm going to start the 7th year with. So it's not going to be U6 that we calculate in this case, which is the trap we may fall into. What we're actually going to calculate is the term U7, because it's the end of the year. Had this said at the start of the year, that would be different. It would be U6 we calculate because that's what we're taking into the 6th year at the beginning in this scenario. We have to do a bit of logical thinking when it comes to questions like this. So they'll try and catch you out with little tweaks and little parts like that. Have a think about the question. Have a think about what it's asking you when you do these sorts of questions, because you'll have to use a bit of ingenuity and a bit of thought sometimes. So for this case, U7, I know that's going to be 500 times the 1.055 to the n minus 1 to the power of 6. Stick that in a calculator. What you end up getting is that U7 is equal to 689.421 and a whole spiel of stuff after that. Now this is money. Remember, money always goes to 2 decimal places. So in this case we round it and we have to give it the units. So U7 is going to be equal to £689.42. So at the end of the 6th year, i.e. the start of year 7, that's the amount of money that we're going to have in our account. We have to make sure we think logically with these sorts of questions. We're at advanced higher now. This is the kind of question we're going to get. It's not going to be quite simple stuff where it says calculate the percentage interest at the end of this, or how much is it going up by. You have to use logic and you have to use thought. But this is the same sort of question as we've had before. All we've done is shrouded it in words and given you a scenario. Think about the scenario and think about the skills that are involved and how they relate to geometric sequences, and you'll be fine.